The topic for the day is chi-square test for independence. Now, before doing the test, let me give you a brief about why do we use this test. It is to find whether two parameters are independent or not independent, to study if there is a relation between the two parameters that we are going to deal. For example, to find whether gender and skin color are independent or not. So here the two variables that we are talking about is gender and skin color. So from now, when you see a question, you have to understand that you have an x parameter or x variable and a y. So you're going to do the chi-square test to find the relation between x and y. For another example, to find whether age and shoe size are independent or not. Again, here you have two parameters which is going to be tested, which is x is the age and y is the shoe size. Now, before moving on to the actual test, let me give you a summary of what is to be done. To perform a chi-square test, first you write the null hypothesis and the alternative hypothesis. So the null hypothesis is defined by H, capital H0, and the alternate hypothesis is given by H1. In some textbooks, you can see HA, which stands for the alternate hypothesis. So it just means the same, whether it's H1 or HA. Now here the key word hypothesis is a suggestion, or you can say an assumption made, where H0 the null hypothesis. From exam point of view, you will always start writing the x and y are independent. And for the alternate hypothesis, you will be writing x and y are not independent. So this is where the whole test begins, by writing the statements which is for the null hypothesis and for the alternate hypothesis. The second step is to calculate the chi-square value. Either you can use it, you can find it using your GDC, or you can use the formula. I'll be showing you both these methods. The third part is to determine the p-value by using your GDC and the critical value. And finally, you have to compare the p-value against the significance level or the chi-square calculated against the critical value. Now, how do you get the critical value and what is the significance level? We'll be discussing all these key terms. Now, let us begin with performing the test on the given data. Question: calculate the chi-square value for the following data. Find if there is any influence between the gender and the t-shirt color preferences. So the two variables that we are going to test here is the gender and the t-shirt color preferences. You can clearly see that the data here is given in the form of a matrix where you have rows and columns. So these are the two rows that you have, row 1 and row 2. And you have columns, first column, second column, third and fourth. So this can be called a 2 by 4 matrix. Why is it a 2 by 4? Because 2 stands for the rows and 4 stands for the column. So usually you define a matrix by the number of rows and columns. So it is row by column, and hence this is a 2 by 4 matrix. I'll start with the step 1, which is to state the hypothesis, and my null hypothesis is going to be variable A and variable B are independent. So this is just a template for you to understand. Every time you have to put the variable A and variable B there. So in this case, I can write gender and my variable B is t-shirt color preferences. Color preferences are independent. So this is a simple and easy statement that you can make by just introducing a word independent. And the alternative hypothesis states variable A and variable B are not independent. Gender and t-shirt color preferences are not independent, or you can even write are dependent. So it's up to you. Now to remind you, the data which is given to you is called the observed frequency. Observed frequency. From now we will be using the term FO, O stands for observed frequency, to define these numbers. Now as a step 2, we are going to make the contingency table from the observed frequency. It's nothing difficult, you just add an extra column there next to the columns that you already have, and you add an extra row below the given rows just to enter the total of each rows and columns. Now here you have the completed contingency table here with all the totals given, where you have the row total which is given here, which is the sum of 48 plus 12 plus 33 plus 57, and the second row total here is 150, which is the sum of 35, 46, 42 and 27. At the same time, these cells give you the column total, which is the sum of 48 plus 35, giving you an 83. Here you have 12 plus 46 giving you 58, 33 plus 42 giving you 75, and 57 plus 27 giving you 84. So this is how a contingency table will look. Once this is done, let's calculate the degree of freedom, which is denoted by the small letter V. Now the formula to find the degree of freedom is R minus 1 times C minus 1, where R stands for the number of rows and C stands for the number of columns. Now here the number of rows equals 2 and the number of columns equals 4. If you take the rows to be 3 and the columns to be 5, then it is an error. So make sure you include only this part of the table to count the number of columns and rows. So here R minus 1 times C minus 1 is your formula. So my R is 2, I have 2 rows. So 2 minus 1 times 4 minus 1. So I have 1 multiplied by 3, giving me the degree of freedom to be 3. Now it's time to create the expected frequency table, and here we denote the expected frequency with the letter FE, E for the expected. Now to calculate the expected frequency of the gender male, preferring the color black. So to complete this cell, the formula that you're going to use is the row total times the column total divided by the total data. Now for this cell, the row total is here, which is 150, and the column total is below 83. So you're going to multiply the row total 150 times the column total, which is 83, divided by the total data, which is 300, and you get an answer which is going to be equal to 41.5. So 41.5 is the expected frequency for this particular cell or this particular condition where you have male preferring black. Now let's talk about another cell here. Here the row total is again 150 and the column total is 58. So I'll do 150 multiplied by 58, which is the row total and the column total, divided by 300, which is equal to 29. So the value 29 is the expected frequency here. Now we are going to do the same calculation to complete all the cells by finding the expected frequency by applying the same formula. So the values are 41.5, 29, 42. Now don't get confused thinking that all the expected values in both the rows will be the same. No, here this is happening just because you have the same row total. So if you have two different totals, for example, if it is 120 and 150, for sure you will have different values here. So not necessary every time you should have the same values. So here we go to the next step. We have found the expected frequency FE, here the table above, the first one. And we have FO, the observed frequency, which is from the question. It's already there. Now the chi-square value is given by the sigma of the square of the difference between the observed value and the expected value divided by the expected value. So this is how you can calculate. In some texts you can see chi-square is sigma O minus E the whole square divided by E. So this is a simpler form and easy to memorize. Now it's time to fill in the table where you have FO, the observed frequency, the expected FE and the difference FO minus FE. Then you're going to square the difference FO minus FE the whole square, and then you're going to divide this difference with FE, the expected frequency. So once you create this table, you just start entering the data. I'll start entering with the observed frequency. Now I have followed this order like this. I started from 48, then I came back and I did like this. So I will be using the same order here. I'll start from 41.5. So I have taken the same order so that the observed frequency here is 46 and the expected is 29. So the order is exactly the same. Now the difference between these two terms need to be calculated. You have some negative signs coming there, which will be eliminated when you square this term. So the next step is squaring this number. Finally, the last column where you're going to divide this by the expected frequency. So 42.25 divided by 41.5. So 42.25 divided by 41.5. Now you have the last column completed and you're going to add all these terms and the sum is equal to 33.76134. Now let me put this answer to 3SF. Now the chi-square value to 3SF is going to be 33.8. Now finally reaching the conclusion part, you must know the conditions to accept the null hypothesis. We have two conditions where the first one is the chi-square value less than the critical value, then you accept the null hypothesis, or you compare the p-value with the significance level, and if the p-value is greater than the significance level, then you accept the null hypothesis. Now I will be using the first part now because I have the chi-square value with me and I need to compare it with the critical value. Now from where can you get the critical value? Now, critical value can be given in the question, or the other way to find it is you have a table where you have the critical values for the chi-square distribution. You have the degree of freedom mentioned here, and here you have the values for the significance levels at which the test is being conducted. The significance level can be at 1%, 5%, or even 10%. Now this depends on the question at what level of significance is the test being done. Now here 1%, which means 0.01, so this is 1% here. So 5% is 0.05. You can say 10% is 0.1. Now for the given data, you had already found the value for the degree of freedom, which is 3. So you have 3. From there, you keep moving to see what is the critical value at 5%. You can see it's 7.815. So your critical value for degree of freedom 3 and 5% significance level is 7.815. So I'll be taking this value. My chi-square is 33.761 and my critical value is 7.815, and here I can see that my chi-square value is greater than the critical. Now the condition states that if the chi-square value is less than critical, you accept null. Now since the chi-square value is greater than the critical value, I'm going to reject my null hypothesis. So my head zero or my null hypothesis stated that gender and the t-shirt color preferences are independent. So since I'm rejecting this, that means I have to accept the alternative hypothesis, which says gender and t-shirt color preferences are dependent. You can say it as they are dependent, or you can say they are not independent. It's up to you. So this is your conclusion. You reject the null hypothesis and you accept the alternative hypothesis.